Good afternoon on behalf of Engineers Australia. I'm delighted to welcome you all today to the webinar, Sustainable Futures, Circular and Regenerative Solutions. My name is Caitlin Balyak and I will be your host, joining from Ngunnawal country in Canberra today. Firstly, and especially in the context of National Reconciliation Week, Engineers Australia would like to acknowledge the traditional custodians of country throughout Australia and recognise the continuing connection to land, waters and community. We recognise Aboriginal and Torres Strait Islander peoples as the oldest continuous cultures on Earth and our first engineers. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted by Engineers Australia's industry partner, SMEC. For 75 years, SMEC has built a reputation as a trusted partner on major transport, water and energy projects around the world. SMEC is committed to positively impacting people, the environment, the clients and the communities that they serve. Through their network of global specialists, their teams draw on deep expertise and systems thinking to simplify the complex and deliver integrated engineering solutions across a range of diverse environments, engineering positive change. Today, we will hear from 4 speakers in a panel discussion, followed by an audience Q&A. I'll now introduce our 4 speakers. So our first panelist is Jessica Carmioni Godbehere, and Jessica is a chartered engineer with 14 years experience working on projects in both Australia and the UK in diverse sectors such as residential, data centres, commercial, mining and metals, and oil and gas. She is passionate about sustainability and structural design and has led initiatives in environmental sustainability within RBG, such as petitioning RBG to sign up to the Business Ambition 1.5 degrees. With expertise spanning structural design, project management, and sustainability leadership, she's played a key role in high-profile developments like the One Waterloo and Cricklewood data centres in London. I'd now like to welcome our second panellist, Linda Norden. Linda is a certified circular economy specialist with 20 years experience in the waste management sector, having delivered projects across the UK, Sweden, and Australia. She specialises in planning and implementing circular economy solutions across solid waste, energy, and water, using a holistic LCA approach. Linda has led feasibility studies for sustainable communities, supported Queensland's first circular resource recovery precinct, and assessed cutting-edge reprocessing technologies. With experience across public and private sectors, she brings deep understanding of risk, governance, and business models that support decarbonisation and landfill diversification. I'd now like to welcome our third panellist, Jodie Finson. Jodie is a qualified and accredited sustainability professional and environmental engineer with over 25 years of experience embedding sustainability into major infrastructure and master plan communities across Australia. Her team embedded sustainability at Inland Rail, delivering outcomes across the design, construction, and operations of the project. Jodie has managed climate risk, resource modelling, sustainable procurement, and has contributed to IS and Green Star ratings for major projects, including the North East Link, Cross River Rail, Melbourne Airport, and Aura. I would now like to welcome our final panellist, who is Dr. Luke Menefee. Luke Menefee is a chartered engineer with more than 19 years of experience. He specialises in deteriorated structure assessment, durability design, remedial engineering, and concrete technology across transport, marine, water, civil, and building infrastructure sectors. Luke's technical publications and presentations include outcomes from his PhD research into ultra-high strength concrete and from asset integrity projects for road authorities, water utilities, and port clients across Australia. Luke also plays an active role on Concrete Institute of Australia's Gold Coast Subcommittee and Australasian Corrosion Association's Concrete Structures and Building Technical Group. I'd like you all to please welcome Linda, Jodie, Luke, and Jessica. Our panel will now come together to kick off today's discussion, and please remember that we'll be taking audience questions at the end of the initial panel discussions. So I'd appreciate if you're able to share your questions with us in the chat box, and if you could also include who you would like the question to be directed to in your submission. So, we're going to kick off with some concepts around circularity in action and understanding how circular design principles can be practically applied to create regenerative outcomes in the built environment. And our first question today will go to Linda. So, Linda, what does circularity mean in the context of design, construction, and infrastructure? And what are the core principles that define circular design, and how can they be applied to projects at their earliest stage?
Thank you, Caitlin, and thank you for having me here today. So I will start with just addressing the fact that circularity is very important for our society today. We've had, in the last 5 years, discussion tripled around circularity, but yet we're seeing circularity dropping across the world. So just the other week at the World Circular Economy Forum, we saw the circularity has yet again achieved less than previous report. So it's very important with the world increasing and our population increasing that we start to apply circular principles wherever we can. The built environment is said to incorporate also at least 40% or more of the global greenhouse gas emissions. So let's look at the core principles of circular economy and how they can be applied to the infrastructure and the built environment. So today I'm not going to really go through these two pictures that you can see behind here. And the circular economy principle was defined in 2013 by the Ellen MacArthur Foundation. And you can see the butterfly diagram here, which I think most people are familiar with. And we also had a shift from the 3 Rs to the 10 Rs. So the 3 Rs was actually something that came into play during the Second World War when resources were scarce. And now today, to keep our resources circulating in our society, we've also included words such as refuse, repair, repurpose, redesign, remanufacture. So if we can move to the next slide, I want to talk about how these circular principles can be applied in the built environment. And this is actually 4 principles that was released in 2023 by the Chalmers University, a Swedish university, and I think it incorporates really well the mindset. So the first we need to do is to design for adaptability. This is to create an infrastructure that can change with time and the needs. So, for example, an old church can become a library in the future. We need to think about designing for deconstruction so that the building that we and the infrastructure that we design today can actually be disassembled at the end of life, and modules can be repaired if need be, and other elements that can be disposed instead. So we're thinking about using screws or joints instead of gluing the parts together. And then also consider resource efficiency wherever possible. In getting inspiration from nature, biomimicry is a word that's often used in circularity to find ways to build lighter structures and use less materials and more recycled content. And that's the fourth option, to choose circular material selection, choose recycled content, choose materials that we know can be recycled or reprocessed or reused at the end of life. So just a little example, if we want to think about, so how do you think about this in an infrastructure project? Well, for example, if you want to build a bridge, you can first of all consider, do we need to build this bridge? Is there a bridge that we can reuse and build from? Could we take that bridge and move somewhere else and use the material that's already there? Once the location has been decided, is there nature, is there elements around that can be used to build that bridge? Is there, how are we going to design the bridge? Are we going to consider a concept that can be easily designed so that it can be disassembled at end of life, easy to repair, low maintenance, and have longevity as well. So those are some of the things we need to consider when we go into constructing and building. So yes, that's probably what I would say to this first question. I hope that's clarified the principles.
That's fantastic, Linda. Thank you. And I think those slides and what you've spoken to them really sets us up for the whole of the conversation that we're going to have today. My next question is for Jess. Can circularity in construction go beyond materials to influence how buildings and infrastructure are planned, used, and eventually deconstructed?
Thank you, Caitlin, and thanks for having me here on the panel as well. Yes, considering circularity in construction can definitely help plan, and will actually change how you look at the structure or the infrastructure. So when we're thinking, I'm a structural engineer, so coming from a structures background, a buildings background, when we're thinking about the use of the space, for example, do we want to have double columns, say if we're doing a modularized system, which could then be reused on another project? Does that double columns align with the architectural space and the use of the space? When we're looking at modularized units and prefabrication, or can we look at something like a bolted connection versus a welded connection, so that we can look at disassembly as well. So looking at things that can be used in one site and then reused on another is very important for circularity. When we're looking at how things can be reused, we are looking at adaptability and what it could be used like in the future. So as Linda showed in the example, a church being reused as a library. Looking at the loading considerations, if we know that we're going to be doing something later on in the life of the building, we can design for that and allow for that. And then also considering that modularization. When we look at modularization, we are looking at a reduction in waste. When we're considering, say, concrete, for example, when we're looking at a site, concrete, I think waste consideration is something like 15%, whereas if you're looking at a modularized factory, concrete waste is around about 3 or 4%. So you can see there that, looking at modularization and producing an element that can be reused again in a controlled environment like modularized units can actually reduce waste as well. And yeah, considering the lifespan of the structure or infrastructure, it can be very, very we can improve the circularity because we're looking at that adaptability, that future use, and improving the longevity of the use of the element as well.
Super. And I think it's pretty hard to argue against some of these ideas. I don't think anyone would disagree that reducing waste, reducing carbon emissions and the likes are good ideas to bring into the construction sector. But I might move to Jody now to help us understand what some of the most significant challenges are when integrating regenerative design into real-world projects, particularly in carbon-heavy industries such as construction.
Thanks, Caitlin. It's great to be here on the panel. Regenerative design, I guess that we need to define what is regenerative design. It's going beyond sustainable design, where we focus on minimizing impacts. We actually want to be leaving behind positive impacts and benefits. We want the world to be a better place than it is now. And I know that's one of the fundamentals of being an engineer and the work that all of us do. But we often get very focused on our individual areas. And I guess the regenerative design space and the circularity space is stepping back and looking at that whole of life of the project from the beginning to the end, doing lots of early planning. So I guess the challenges of how do we integrate regenerative design and into construction is we need to be challenging our asset owners. Who owns the project? We really need them to drive these processes and outcomes because they need to have ownership. We can do this, but without their support, it can be quite challenging to try and drive some of these things through the process. We really need to make sure that we have early, fully integrated whole of life planning. We have to plan for success. And we also have to think outside the box. We can't just keep doing what we've always done. We actually have to start challenging ourselves and challenging our designs and our briefs. We really need to look at how can we go beyond where we currently are of minimizing impacts and focusing on maximizing benefits.
And before I move to the next question, I might just ask Luke, Linda and Jess, if you have anything else to add to some of those challenges and how we might overcome them.
Yeah, I was just going to add, look, some of the challenges, in the engineering space and the take up of a lot of innovative low carbon materials, and I'm wearing a concrete hat here, is limitations in available standards and that long-term data. And I think a lot of the industry is aware of that, and we'll probably talk to that throughout this session. Is a lot of authorities are trying to catch up to that data quickly and provide confidence to the engineers that we can push the boundaries on a number of these low carbon design solutions. So yeah.
Linda and Jess, was there anything that you folks would like to add? Are you happy for me to move to the next question?
No, I think it's fine. We can move to the next questions because I think we will be sharing some of those challenges later on as well.
Yeah, not a problem. Super. Well, I might just bring it back to Luke then to start with this one, which is, what are some of the opportunities and challenges with low carbon concrete mixes or design methods that reduce environmental impact while extending the life of an asset?
Yeah, thanks, Caitlin. My background is obviously concrete technology and durability, and it's a subject dear to my heart. Look, the first opportunity we take in low carbon concrete mixes is really focusing on that very fact. We want to reduce carbon content, and I think it's well established out there that we're using supplementary cementitious materials, and we're increasing those. The amount we're replacing into concrete mixes significantly, and I think a lot of asset owners and authorities are starting to push limits on how much we are replacing GP. That's the major culprit in CO2 emissions. So when we're looking at standard mix designs, we could be looking at up to 70% replacement now. Is not uncommon to be a requirement, and that gives us about a 60% reduction in carbon emissions. The other opportunity is in long-term durability. So designing assets to last longer lives. So we're not back there maintaining them. I think Linda sort of set the scene in that early on. And a lot of these low carbon mixes, I think the industry might see them as potential increases in cost. But in these environments where you've got higher durability risks and longer life requirements, incorporating supplementary cementitious materials, it's well known that it gives you durability benefits. So standard marine grade mixes are 70% supplementary cementitious materials. So the other parts that the industry's, it's quite normal now to use triple blend mixes for a lot of large cast elements. So I think that's well known, and the industry's catching up in terms of trying to ensure on projects we have minimum SCM levels. A few years ago it was only 10% to achieve certain Green Star ratings. Now it's actually, on some recent New South Wales projects, the clients are actually driving at 50% minimum levels across all elements, which put a challenge to the design team, but they've delivered that. The other part, other opportunities is obviously utilising other byproducts. Fly ash, slag, all of these have a limited lifetime with their raw material extraction and processes. So the industry's fast looking at alternatives such as calcined clays, and there's some really promising projects already off the ground considering that, and other parts of waste products from the energy industry that traditionally weren't considered usable because of their variable quality. They're starting to push the limits to say, okay, how much can we actually include and not affecting the performance of the concrete. The challenges, I think, is what I've probably picked up before in the question to Jody, is that the concrete still needs to have a technical, meet the technical requirements for the project. That's structural and durability. So it's traditionally seen some low carbon solutions as variable quality, and I think that confidence needs to get out there that you can actively have consistent quality concrete with various types of low carbon concrete options. There is a lack of standardisation, which engineers like standards, they like reference guides, they like black and white. So I think that is improving. Standards Australia have got guidance documents out on alkali activated materials. And again, I think clients and asset owners are driving this as well. So Austroads has about to release a guidance doc on low carbon concrete, which really starts to push the boundaries as well. Long-term data, clients are also driving at research programs, linking in with unis and industry to actually fill that gap quickly, because that's often seen as a barrier to the uptake of a lot of low carbon solutions. Thanks, Caitlin.
That was awesome, Luke. And I might just bring in Jess or Jody if you had any other comments on the low carbon concrete question.
Yes, yeah, I've got a few. A couple of great points raised there by Luke. Innovative technologies and the standards. So I'm coming from a European background here. I know the Eurocodes have released a new British standards which incorporates the new ternary mixes, which becomes sort of a new baseline to reduce embodied carbon. So I think that was a very forward-thinking thing to do in terms of releasing a ternary mix as a sort of base standard with limestone mixing with the GGBS or fly ash. So market availability can be quite changing. So if we're looking at a alkali activated cementitious material, majority of those are using like a GGBS mix based in with other things, and sometimes the supply of GGBS may not be able to meet the requirements. So we've got that kind of flux in the market availability of some of these additional mixes, which can be seen as a challenge to the supply chain. Some of these innovative technologies we can get through the standards with testing. The standards do allow us to do that, which is great. Some of the challenges with that is that not everybody knows what requirements are for the testing to be able to write the specification to provide that testing and that guarantee for the engineers to sign it off. That's becoming less of a problem though. We are also seeing the codes being able to benefit us in terms of adapting to some of the new innovative materials. I know there was a report in Europe, I think it was based in Germany, that allowed AACMs to be used in the mix of opportunities for concrete mixes. So hopefully that spreads based on the testing and the data that sort of compiles behind it. Another sort of challenge that I see with innovative products is insurances. Sometimes when we're late in the project, it's very hard to get insurances on board because you've sort of done a project up to a point with one kind of concrete mix or one supply in mind. You then turn around towards the end of the project and then change that. And insurances can be, with new and innovative materials, you need to take the insurance companies on the journey. So that can be a challenge as well. But if you're early on in the process, you can bring them on that journey with you, introduce them to the testing regime you're doing, and then get them on side. So that could be a great opportunity as well in the project.
Yeah, super. We see that challenge a lot with climate adaptive design as well, I guess, in that you should get a lower insurance premium if you are planning for future risk, but we don't always see that reflected. I guess, Jody, did you have any final comments on low carbon concrete before we move on?
Yes, I guess one of the challenges, but also the opportunity, is actually, can we design in trial use of these innovative materials, even if we're not using them for the whole of the project or the design? Can we still use them and incorporate them and provide trial sites for industry and for the community to get a better understanding of how these are working and how we can manage them? So I think that's a really big challenge to be able to provide those trial sites, but it's also a big opportunity for us as well. We can get firsthand experience using them. Our construction partners, everybody involved in the process can get that experience, and we can learn from that and take that on board. And I assume that'll make the conversations with insurance and other areas a lot easier to have those conversations because we've got the trials and the information.
Well, speaking of real world examples of how these things work, I'm going to throw next to Linda and ask if you might be able to share some examples of projects that you've successfully implemented circular economy principles, and what were their outcomes in terms of the resource conservation, cost efficiency, and environmental impact on those projects.
Okay, thank you. So I will just share just a general sort of project that SMEC has been involved with, and it's very close to where I also sit, which is on the Gold Coast, and where a high IS rating was achieved, and that's when M1 was upgraded between Varsity Lake and Burley. And some of the circular principles that was applied on that project was, for example, they were looking to use best practice that hadn't been used in Australia, so it was an Australian first. And I should also say there's some more information to read about this project. There's some publicly available information if people want to know a little bit more about it. But so the first thing was to actually use the concept of concrete fracturing, which means that they apply that concept that I discussed in the beginning, where you're looking to use material that's available on site and reviewing what of that material can be reused and integrated into the actual project. And whilst you do these kind of, when you apply that method, you are also reducing the cost for the overall project, because you do not have to transport that material away. You do not have to buy that material into the project. And this is a true cost saving, and one of those, methods that truly can show cost efficiency for the project. And then the other thing that they also did, which was great on this project, was that decided to reuse the flyover, so that the structure of the bridge was rehabilitated instead of rebuilt. And again, that saves cost, because you're not having to buy new raw material, but instead you're focusing on rehabilitation and repair, which is again a really good saving, not just for cost, but also for the environment and carbon. And I guess when we talk about these projects, it's important that it was a long project. So it was made in stages. What also happened on this project was the knowledge share. So whatever was successful was then transferred onto the next stage and the next stage and reapplied. So very often we actually don't have to reinvent the wheel. There are so many examples these days that we can use, but it's important that we do use them and we do implement them. And I actually want to hand over now to Luke, because you have some lessons learned from this project on how it was to work and collaborate and knowledge share during this project.
Yeah, thanks, Linda. Look, I think probably a couple of points with our team's other hat is obviously reusing existing structures. And I think it's easy to say, look, we'll just incorporate that into our new project. But engineers like to have a technical basis for that. And I think on this project, it was a great example of that. Linda spoke to this flyover retention. It was a significant bridge, and retaining it, I can't remember I think it saved thousands of tons of wastage. But it also is maximising, the residual life of, some significant bridge assets. But to do that, the team has to, properly assess the structure, and that has to be done early on. And like Linda was saying, the early engagement is important to get those decisions early, and ensure that you can get the most out of what is there, and do we have to widen the footprint? Is our assessment of that existing site and existing structures sound? Are we confident? Are we making the best decisions on that? I think, and that sort of extends into other materials, and the pavement fracturing piece that Linda spoke about, what they used, using all those recycled pavement as a sub layer for the new pavement. really required close collaboration between contractors, designers, with the state authority as well, right through early on in the project. They had to ensure they had trials and testing that would support that for a 100-year life, which is quite a good outcome. But again, it just goes to show the importance of early collaboration on these projects. Thanks, Linda.
Yeah, the sooner the better really is key when it comes to all things circular economy, not just in the built environment. Thanks, Linda and Luke. My next question is going to be for Jess, and it's around what role does digital technology play or data analytics in improving material tracking, resource efficiency, and waste reduction?
Thanks. So one project I worked on where we had a real significant impact due to the sort of digital tools was One Waterloo. So it's a structure proposed to be built over the adjacent tube lines to Waterloo Station. So very significant spans of 106 metres between sort of available piling areas. We were able to go through a process through our digital tools where we changed the design of the truss into something that's more organic, which ended up being about 30% less structural steel. So digital tools have a massive part to play in sort of resource efficiency in terms of putting material where material is needed and not just putting sort of blanket transfers everywhere. And digital twins, so the real benefit we've got of buildings today and designed in the last 20 odd years is that we've got those digital backgrounds, the digital data for the information that we've built. So when we're looking at circular reuse and reusing elements again in a different building, we can go through those digital blueprints and find those elements, what elements are in the building, then go and inspect the building and find out how likely it is for them to be reused. And we can basically use them as sort of a library of parts. So one of the key challenges is the buildings that are coming down today, built 50 odd more years ago, don't have those digital tools. So we're doing a lot more physical inspections to try and get that information. So what this allows us to do is, even though we're doing the physical inspections, we can come up with a digital twin of what has been inspected and look at how that element can be reused. So that can then go into a library of parts. And I know many of the steel reuse companies have a digital library of the elements. We can then go through and then sort of see how we can reuse those in our new construction. Timber also, sort of material tracking, and timber and steel are doing quite a lot of this as well. So material tracking is very important because we need to know have confidence in where the material has come from and the confidence in the factors that we're using for when we're calculating our embodied carbon. So material tracking and designing for disassembly can change, can impact those numbers as well. So looking at the waste management, manufacturing plants having a lower waste, but they do have a controlled chain of custody. So yeah, material tracking can really impact where we are going and how we look at our embodied carbon for our project. I believe this is not mandatory in Australia as yet, but it is a key tool that we can use to track carbon on our projects.
Super. I might just keep Jess in the hot seat for a moment because my next three questions are sort of around designing for disassembly and reuse. And so, Jess, as first cab off the rank, what are the fundamental benefits of designing for disassembly in the context of both sustainability, but also for long-term cost savings?
Yep. So designing for disassembly has some really key uses. I mean, we're not going to recycle our way out of this, as Will Arnold keeps saying from the Institution of Structural Engineers. And so we need to be thinking about reuse. And one of the ways that we can reuse is by designing for disassembly. When we're thinking about connections, when we're thinking about the use of the space, how practical is a 20-metre steel beam going to be in the next project? Looking at standardization of parts, standardization of connections, things that can be transferred from one typology to another easily, without having to be, refabricated, etc. So having a look at one of our projects, some areas integrated project office. We have a steel CLT hybrid. It was a temporary office originally for one of the station's developments. We have developed that into a modular system, which can be moved and reused because there's multiple stations that will be built. So looking at that sort of circularity of not just using the office for one area, but actually being able to transfer and then move that, disassemble that piece, put that to a new site, reconnect it, and then reuse it. So it is a change in the philosophy of how you design. So, looking at the space, are double columns acceptable? Are standardization of column spacings acceptable for the space? It can really sort of improve the sustainability of the project.
Fantastic. And I think, again, coming back to the point of that it really is a total shift in the way that we think about doing things rather than just tweaking around the edges is what makes this kind of process work. And to allow you to draw a breath, Jess, I might just flick to Luke now on how can principles of disassembly, reusability, and adaptive reuse be integrated into the design of modern buildings and infrastructure, especially those that are not originally intended for circularity, without compromising the functionality and the aesthetic of the build.
Yeah, thanks, Caitlin. Look, I'd start at, from an infrastructure perspective, when we look at construction, we look at modular systems, and I think Jess pointed to that. So how can we, I suppose, streamline the additional transport costs, actual construction time, which creates, a lot of transport movement. So precast systems generally offer that. I think Jess spoke to some of the, the connection detailing that enables us as a fundamental principle to, welded versus bolted enables us to sort of, disassemble things. There are durability issues in that context as well that are sort of a counter to that. So we've got to balance the need for disassembly with long-term durability as well. It just depends on what the design life requirement is. Look, in the bridges space, it may not be disassembly, but a number of components that have to be replaced throughout the life, which is just a function of their components, like bridge bearings, are significant things that may need replacement within the life. And we, the designers, actually have to think about how that's going to happen. So they, for a given headstock, they'll put in a jacking shelf so that the actual bridge can be jacked up to replace the bearings. That's obviously in situations where we can't put in bearings that are going to last 100 plus years. So I think there's some of the aspects around the disassembly and replacement within a design life. The other consideration is designing for maintenance. So painted steel structures, the designer has to think about how are we going to get access to repaint this all effectively. And this comes into the initial material choice. Is that going to be viable? Is that going to be the lowest whole life cycle cost for the design life? So, in some bridges that, some historic bridges, Sydney Harbour Bridge, Story Bridge, they've obviously got permanent access systems installed. They're massive, iconic structures that have permanent maintenance teams. So things like that, you wouldn't think you'd get off the ground now with that much life cycle cost. There's a lot more efficiencies they could gain. So yeah, I'll probably pass it back to Jess to dovetail it back into the building space.
Thanks. So looking at the buildings, and when we're sort of talking about adaptive reuse, we could be talking about something that has been designed, but is then sort of changing from one use to another, which I've had before, or we're dealing with an existing building, which we're then sort of retrofitting or adapting for a new purpose. Sometimes changes can come in that we can't predict. So, for example, fire escape distances may change during the design process, or having looking at a building from 20, 40, 50 years ago, it could be different from quite now. So, how do we kind of account for the changing requirements and build that in? So, when we're looking at different designs, we can look at sort of optimization or adaptability. Sometimes they don't always go hand in hand. When we're looking at sort of adaptability, we're talking about the potential for the structure to live maybe beyond 50 years. We're looking at maybe a 100-year lifespan rather than a 50-year lifespan, and potentially that adds additional material into the structure. But we don't have to sort of do the inspection and checking and potential strengthening or rectification works after 50 years. We can leave that to 100 years, versus a lean design question. So whether or not we go for a fully optimized, lowest material possible, but it is built for that particular use. So they're two very sort of different approaches. But when we're focusing on, we need to be considering what the building is going to be used for when we're looking at those sort of questions. Something iconic, you might want to end up with the 100-year kind of design life, because we're looking at something iconic. It's going to be around for a long time, or it's above a station, and that's quite a critical building. We need to protect that for a long period of time. So the sort of different project requirements can sort of lead you down a different path. So sourcing of materials as well. So when you're looking at something that's sort of designed already, but you're yet to construct, but you haven't included that kind of circularity piece in the beginning of the design process, you can look at sourcing your materials. Where are you getting your materials, and having a look at opting for circular or less carbon intensive materials. Looking at waste reduction and management. So whilst disassembly may not have been designed in, you can look at maybe manufacturing or prefabricating some elements and bringing that to site. But as Luke mentioned, you do need to be considering logistics as well. It's all well and good to fabricate a 40-metre span truss, but you've got to get it to site. So, you do have to be thinking about logistics and construction as well. If you can't lift it, or you need the biggest crane in the world to lift it, probably not a good way of going about construction methodology. And yeah, we touched on points before, such as, considering the connection types. So whilst you may have gone down a route of welded connections, you may be able to change those retrospectively, but it would sort of require some redesign to change to a disassembly.
Thank you, Jess and Luke. The next question is potentially the one that I'm most interested to hear about. I'm really interested in the adaptation mitigation nexus, and we can get win-wins on carbon and adaptation. So Jody, I might bring you in for this one, followed by Jess, for how does disassembly and reuse directly contribute to climate resilience as well as emissions reduction? And can you share some examples of where these benefits have been realised in projects?
Thanks, Caitlin. So I guess climate resilience is an area we really have to design and construct for. We have a changing, unpredictable climate future. You can see this with the recent flooding that's happening in Taree. So it's really important for us to understand what our risks are with respect to climate change. So we need to be looking at our future climate. We need to be looking at flooding, extreme weather events, rain, drought, fire, bushfires. There's a whole range of things we need to be looking at and considering. We need to look at how our building and design, how we're contributing to the carbon going into our atmosphere and contributing to climate change. So we're very much looking at how do we design, optimize our design for a changing climate. An example would be we might have to build a slightly bigger, taller, stronger bridge to deal with increased flood requirements. But then we've got a bigger carbon footprint. So are there opportunities to then look at design or other options to reduce our carbon footprint in that space? or can we look at other opportunities such as incorporating I don't know, recycled concrete materials or other materials, other waste materials into that structure. So it's very much having designing fit for purpose. You have to make sure that you're addressing risk and that you're meeting your design requirements. But it's also, I guess, stepping outside the box and looking at, are there opportunities to reduce our carbon footprint so that we're not contributing to future climate change? So I guess that's one of the big challenges we have, especially in the concrete space and structures as well, because when we're designing things like bridges, we have to make sure they meet the requirements for that particular piece of infrastructure. But are there opportunities such as possibly reducing the depth of the bridge decks so that in one aspect, you're reducing your carbon footprint by reducing your material use. So I think there's a huge range and a huge opportunity to kind of step back and go, what do we have to do? How can we challenge those requirements? Do we have the most up-to-date specifications? Have we looked at all the opportunities for reducing carbon? How can we think outside that box but still meet those important structural requirements that we have for our buildings and our infrastructure? So even including, is it possible to include, if we want our bridge to be green, can we include materials in the concrete mix so that when the final bridge is done, we don't have to paint it. We've actually now got a green concrete bridge. It's challenging those requirements. Do we have to paint it every year or every 5? How can we minimise the carbon footprint of that piece of infrastructure? I'm sure Jess has got some good project examples as well.
Jess, to hear about some of those examples.
Thanks, Jodie and Caitlin. So yeah, looking at climate resilience. So for example, I know our civil engineers, they design for a higher climate flood level compared to what we would have done, say, 5 or 10 years ago. So we do incorporate that sort of climate resilience into our designs, and that comes out in sort of size of attenuation tanks, opportunities for water reuse on site. So that we're sort of bringing that climate resilience to our projects, even though sort of we may not have had to build a foundation or a basement up as high as we maybe would have done under previous designs or previous requirements, but making sure that the designs stop the sort of the flooding on site, or then capture that flood water, and then we can redistribute it in a positive way for the local environment. I don't have a specific project, unfortunately, but I'm aware of quite a few projects we do it on. But I mean, climate resilience, thinking about how we can design for climate resilience is very important, because it will increase the lifespan of our infrastructure and our buildings. So when we have a building with a large amount of windows, we end up with a very high solar and hence heating requirements or cooling requirements for the building, I should say. So, having a look at how we can then sort of balance different facade types with glazing, with then the demand on the cooling systems can have a big impact on the units that we need, and then hence the loading on the slabs and things like that. So we need to be considering the holistic approach to structures, to infrastructure, to be able to get a lowest and best for project carbon reduction.
Yeah, those energy efficiency examples are really good, because, of course, thermal comfort in a warming world becomes really important, as well as reducing our energy usage. We might just stick with Jess and Jodie for this next question. The next few questions are going to be around adaptive reuse and longevity. So we'll start with you first, Jess, and then go to Jodie second, to switch things around. But how do we encourage the widespread adoption of adaptive reuse especially when facing design constraints or regulatory challenges?
It's a great question. It can be quite challenging. I think one of the first port of call we need to do is educate our colleagues, our clients, our collaborators. In education, we can share our knowledge and then also bring everybody up to the same level. We need to be challenging the brief and empowering other engineers to understand how we can reuse a building, how we can provide testing requirements, and sort of education and sharing that knowledge is sort of the baseline of I think how we encourage widespread adoption. When we don't know something, we're often very scared of it and step back and wait for somebody else to do it first. Particularly as engineers, we like to see that it's been done and tried and tested first. So, in order to be those early adapters or early adopters, we need to be sort of educating ourselves, challenging the brief, empowering those around us to bring us all on that journey. And regulatory challenges, we're seeing some changes already, particularly in the UK and London. So we've had the early adopters for a few years put requirements into their contracts, say for reviewing a building for adaptive reuse before we go through a process of new design. That has now come into a regulatory effect for the Greater London Authority. So any new building in the GLA, the Central London, needs to go through a process of evaluating the existing building and justifying why or why not parts or the whole structure can or cannot be used. So it's very, we're starting to see those kind of changes come through in regulations, and that will bring kind of those late adopters up with the rest of us. But yeah, it is really about educating ourselves and others.
I guess, Jody, did you have anything to add to Jess's comments just now?
Yes. I think that there's a huge opportunity to be early adopters. We don't tend to be very keen to jump into new areas and be leading in the innovation space. I know risk is a big constraint in Australia, but I think we have an opportunity to definitely look at where we can do things different but better, and we can start working with bits and pieces that we've already got. We're already value engineering all of our designs. It's just adding some extra elements to that. Is there a carbon saving here? Is there other benefits that we can highlight? I think one location or one state in Australia, Victoria, they've brought in their recycle first policy. And I think that makes all of our projects plan and consider adaptive reuse and recycling, so that it is front of mind. It's not something that's scary. It is something we have to plan early, and we have to do it well. And I think that's the piece that we're sort of missing at the moment, is not necessarily the drive to make change, but what does good change look like, and how can we manage that within the framework of engineering and safety and risk. So I think there are constraints, but I think there's big opportunities as well.
Yeah, and I think we heard from Luke earlier about when you point out some of the co-benefits of things like the increased durability you get from using certain recycled materials, it's easier, I guess, to make some of those arguments. And our next question is for Luke, around what strategies can enhance the durability and adaptability of concrete structures to support future reuse or repurposing, and how can material life cycle assessments inform decisions around mix design, structural systems, and detailing balanced embodied emissions with long-term performance?
Thanks, Caitlin. Long question, but it's a good question, and I'll focus on the word reuse. Like when we're building a bridge, I think it's different in a building setting. We want to keep that adaptability for change in use. Bridge, yes, we want to be able to reuse them, but we generally don't want to be demolishing bridges if we don't have to. So our focus primarily is designing for longer design lives. So, transport authorities are now pushing 120-year design lives. They're looking at options in their contracts to say, look, when it gets to year 80, what are some additional things we can include in the design now to give us a 50-year life extension? So that there's some things that we can include in the design, like for example, full electrical continuity of the reinforcement if we're in a marine environment. That gives us an adaptability measure to include cathodic protection at year 100 if we think it's going to be needed. That comes from learnings on reusing existing assets and some of the challenges we have when we have to repair existing concrete structures. So I think you're focusing on that design life, but also picking up on that climate change. How's the exposure environment going to change? So for bridges crossing saline, tidal rivers, we need to understand how far that climate change is going to get and how far sea level rise is going to get. And we factor that into the durability design, and that informs how much cover there is on the concrete. That informs the durability requirements we need. It may mean that we need stainless steel. There's some of the measures we need to include in the design. There is the other piece around, avoiding over-specifying as well. So if we're clear on those design life requirements, we can target where we need high performance materials and where we know, we're going to need to, build another asset in that location at year X. So we're not over-capitalising on assets as well.
Thank you, Luke. And we'll move back to Linda with this next question around what are some of the key challenges in conducting accurate and comprehensive life cycle assessments, and how can they be addressed?
Yes, thank you. So I actually want to start with saying that I think an accurate LCA actually can make or break a decision. Like a circular decision cannot be made because of an inaccurate LCA. And I just want to also say that the most important thing is to get the scope right. And I'm going to use an example of that, which is perhaps a bit controversial. So we know that we're all one of the circular foundations is to use renewable energy, renewable fuels. So we are trying to electrify our fleets and a lot of the equipment that we use on sites, etc. Now, that's all very good, but if we look at the LCAs that are usually being made for using electrical vehicles or equipment, very often we talk about there is a zero carbon emission whilst we're using the equipment, but we have to look at the whole life cycle here, because one of the things obviously is that you need to also use renewable energy for it to be carbon neutral. The other thing is if we look at transportation, electrical transportation, then very often there's a manufacturing part as well. You need to manufacture the vehicle. Oftentimes, manufacturing an electrical vehicle actually requires more energy than to produce the normal vehicles because of the battery, etc. And then we also have, when we come to end of life, and this is very interesting aspect that there is obviously a lot of batteries that needs to go for disposal. And here in Australia, we are yet to see reprocessing infrastructure for batteries. And this is actually one of the areas where I guess I work a lot in myself, being in the waste and resource industry as well, to really make sure that we have somewhere to send our, if the waste from infrastructure, waste from the built environment, or the batteries, for example, at the end of its life. So there are possibilities to use them for data centers for a few years after they have come to end of life. And today, just to see to talk about the significance of this problem is that today we have about 3,000 tons of batteries, lithium-ion batteries, being produced. But if we look at just about 10 years ahead, 2035, we're looking at possibly 150,000 tons of EV batteries coming to end of life. So it's very important that we also not just think about designing right, but also designing the back end and designing a life cycle analysis that can, includes all the steps along the way, and also understand that there is an infrastructure at the end of life. And if we don't have that, maybe that actually isn't the right solution for us at this particular time. So I think the scope of an LCA is so important. And I also think it's important that we take care and we do this thoroughly. So I've seen on some projects that I've been involved with that the wrong decisions can be made also in regards to using recycled glass or recycled steel, etc., because not the persons that are making the feasibility or the LCA for if this material should or should not be used on the project may not have the knowledge to really make that decision. So it's very important when we work on large projects that we use specialist knowledge and we work together to really, technicians works with someone like myself with the circular aspects, so someone from the sustainability team, water everywhere, so that we combine and collaborate to get an LCA that we can trust will make the right decision for us. So I hope that makes sense.
Yeah, and we might just stay with you, Linda, there, because sort of on the point of having the right knowledge for the job, I guess, are there any misconceptions or that you come across regarding circular design approaches or resistance, I guess, that the industry might have, and how do you think we might be able to address those?
Yes, certainly. So yes, I would say the biggest misconception, because we've heard everyone talk here today about all the fantastic examples of things that are being done already today. There are circular and sustainable initiatives, and it is that it's too complex, it's too hard, it costs too much money. Because all of these things are actually not 100% accurate. So we're today living in a world where we most of the time think that it's in the too hard basket. And with our mindset thinking that it's a little bit unfamiliar, how are we going to introduce this? And maybe I don't have time to do this. It's also coming with the fact that it is unfamiliar ground. We're breaking into something that we haven't really done before, and we need to master it. We need to learn to master it. And this needs to be a process. So if more people actually challenge, like Jody was talking about, you challenge the brief a little bit and think like, hey, what can I do? Oh, the client hasn't actually asked for this, but you know what? I've seen this done before. So let's challenge the brief and let's try to move one step further. A way to approach this is we've actually sort of created like a 5-step approach inside of SMEC. So that you can sort of have something to follow, and it becomes easier if you have a step-by-step approach. And that is really that you try to define sort of the baseline when you start the project and see, okay, what kind of circularity or sustainable targets can we set for this project? What have we done before internally? Look for clues, look for success stories, and then embed this into the project, align it with or take guidance from these standards that are available, like the ISC ratings, the Green Star, the new ISO standard for circular economy that came out last year, which talks about the shifting from the linear to the circular business models, which we can also use and take advantage from when we build and when we create new infrastructure. And then it is working together to really assess if you're uncertain, assess the feasibility, reach out to people that has worked with this before, and maybe it isn't so hard to sort of go that one step further, and then try to implement. We stop talking, like we said, like I mentioned in the beginning. We talk a lot about circular economy, but let's also action it. Let's put it into implementation and see how we go. And perhaps we didn't succeed the first time. Okay, but we're engineers, so look at what went wrong and find a solution and make it better the next time. So I think that's really important, that we really are not worried about doing the wrong thing. There's actually, and I have to say this, there's actually been a research done by a man called Mark Green, and he assessed that there's actually costing the society more when we do nothing. So when we just sit and think it's comfortable, no, it's too hard, or it's too risky, that is actually costing us more than to make a decision and action it and try to move forward. So I think this is the misconception, that it's too hard and we can actually do more than we think. So it's a mind shift. We talk about circular economy being changing a system and changing the mindset. So that's where we need to start, shifting our own mindset and move in the right direction.
It's probably not just a good lesson for engineering, but for life, to when things go wrong, we'll do a little bit better next time, and not being afraid to learn from those lessons. So I guess sort of on the point of innovation, we'll go to Jess and Luke on what role innovation actually plays in improving the longevity and adaptability of buildings, and how it can help address the challenges posed by resource scarcity.
So I'm going to use concrete as an example here, but the GGBS world reserves are becoming increasingly lower. When we're looking at the new AACMs, the alkali activated cementitious materials, they often use the high GGBS quantities. Now we're seeing increased GGBS uses across the platform, where specifying concrete mixes with 50% GGBS, 80% GGBS as cementitious replacements. However, we do have a limited resource. It is a limited resource. Innovation is helping us move in a different direction, using ground cement from existing structures as a cementitious replacement. That is currently only in testing level at universities in Europe at the moment. But that is a great example of how we can use innovation to recycle some of our old structure, and particularly concrete, which is very hard to reuse and cut out and reuse in another site. But looking at how we can actually lower our GGBS reliance, save that for when we need it, as sort of a performance-based criteria, rather than blanket using it because it's a lower embodied carbon material. And so I think innovation has a key role in getting us to net zero, and the current results show that without innovation we won't reach net zero.
Yeah, fully agree, Jess. And I think another key area is ultra high strength concrete. Look, it's a subject dear to my heart, but that gives us the ability to dematerialize our projects. So it is in itself a very carbon intensive product, but it enables us to, say, for example, produce a bridge with 90-metre spans. So we can basically avoid 2 to 3 pier sections. So significant material saving. The other benefit is, design lives in the order of 300 plus years. So the industry's already has applications of that. It's been used a fair bit overseas, and the Australian Standards Committee, I think AS 5100 Part 10, is under development to try and recognise how ultra high performance concretes can also benefit sustainability.
Thank you, Jess and Luke. I guess our next question, we're going to look into some of the economics of circularity. I'm sure that we will come up against instances where sort of the cost is the key focus on a particular business case with a client. So I guess for Jody and Jess, what are some key examples where circular design has provided a significant economic benefit, either through cost savings, resource efficiency, or even risk mitigation? We'll start with Jody, then go to Jess.
Thanks, Caitlin. One of my favourite examples is from Inland Rail, and it was the understanding, I guess, at the earliest stages of planning for the project that there were going to be material supply constraints. There was a massive amount of fill material required for the project, spanning from Melbourne all the way up to Brisbane. So we were looking, or the planners were looking at how can we source these materials, how can we do it efficiently, how do we make this happen. If we can't make this happen, we're going to have massive cost impacts, we're going to have massive schedule impacts. We need to come up with a solution. So the opportunity that was identified was the use of on-site material for fill. However, a lot of the project areas had reactive soils, and there was no allowance for the use of that material in the specifications. So there was this tension between there's an opportunity, but it didn't fit the specifications. So the challenge then became, how do we update or improve our specifications so that we can reduce this risk or remove the risk. And the actual process was found to it took about 2 years. I think part of the issue was when they started looking at how do we, what's the process to update and modernize our specifications, and they found they didn't actually have a proper process. So it became looking at that. It became an issue of looking at that whole system of how do we manage our specifications, how do we manage those, how do we update them, what's the process, how are we comfortable with these changes to be signed off and to be implemented. So as I said, it took a good 2 years. You need to identify these opportunities early, you need to plan, and you need to action them. As Jess and Linda said, even 80%, getting 80% done is a huge change. It might not be perfect, but that's a big change and it's a big start. So by changing these specifications, it allowed the projects to use reactive soils as fill material. They did have to add, I think it was lime and other things to it. It was an engineered solution, but it did allow them to reduce the risk to their schedule. They knew they had supply, and it actually had massive environmental benefits and social benefits too, because they reduced their carbon footprint. All the processing and handling materials was on site. It was not imported from off site. And it also had flow-on benefits for the local communities. There were less trucks on the road moving fill materials around. There was less damage to the local council roads. There was less noise and disturbance as well. So, it seems like a small change, but even these small changes can have massive benefits and impacts. So I think it's a really good example of how we can sort of think outside the box. We can't do it because the specifications don't let us. Well, actually, let's challenge that. Let's actually step up and go, how can we make this better? So I think that's a really good example. I'm sure there's lots of other more recent amazing examples, but that's one of my favourite because it spans that whole planning, design, construction phases of the projects, but also addresses that issue around specifications and standards.
Jess, if you had maybe one favourite example to add in the mix there too.
I do, yeah. I've got a favourite example, but I'd like to preface this with saying this is not my project. I didn't get a chance to work on this. We had there's a developer in London, Grosvenor, and they were very passionate about sustainability and reuse of structures and Lego libraries. Not sure if I can use that word, but using a list of parts to then rebuild a new structure. So what they did is actually they looked at their portfolio, saw what buildings were coming to the end of their life, and actually dismantled a structure, refabricated the steelwork, got it all tested, got it refabricated, and put it in a new structure. So that was a massive, resource efficiency. They brought in, I think, minimal, like 5%-ish new steel, but were able to reuse a lot of that existing structure to build a new portfolio building for themselves. So yeah, I thought that was very, very interesting. And now that they've done that, they've got a digital twin of that structure, so they know exactly what's in there, and then they can do that again in the future.
That's a really exciting project. And I think sometimes our favourite projects are projects we don't work on ourselves because we don't necessarily get the negative as well as the positive from those particular projects. I just have two more sort of questions left for the panel before we move on to audience questions as well. But this one sort of wraps in something that an audience member has asked. I'll direct it at Linda. Are there any regulatory challenges or gaps that need to be addressed to make circularity more mainstream in construction and infrastructure? We've sort of, I guess, had an inquiry as well from Munji from New South Wales. Is Australia looking to develop any national standards or frameworks, I guess, sort of to get over some of these regulatory hurdles?
Yes, so the answer is definitely yes. There are regulatory challenges, and there is a lot the federal government and state governments could do to assist and drive this the circular development within the construction industry forward. And I just want to mention first of all as well one of the things that is missing, I think, at the moment is the strong linkage with circularity and the reduction of greenhouse gas emissions. It isn't very strongly linked together, and actually, I'm not sure if anyone else has had the chance to listen in to some of the sessions from the World Circular Economy Forum that was held 2 weeks ago. But some of the things that were raised there is also that there is the current reporting framework where we report on greenhouse gas emissions, scope 1, 2, and 3, is actually working against circular actions. And this is probably, the discussion was around this probably because the framework was set in the 1990s. It was built around a linear module and a structure. So examples like if you want to produce for durability, if you want to use a rental model, which is circularity, where you have products as a service, the greenhouse gas emissions that you calculate will actually look worse for you. And this is obviously a problem and a regulatory issue. This is especially important for Australia, who's introduced the reporting of greenhouse gas emissions. And there is a clear then, probably not very well known yet. And this is the fact that circularity isn't so familiar and hasn't been embedded properly in the economic models and also in the greenhouse gas models, that we really need to look at how are we encouraging circularity. And the other thing I would say is we have targets on projects where we need to divert about 80% of our resources, and also in the Australian Circular Economy Framework that was released last year, there is a target to safely recover 80% of our resources. Now, the problem is in a construction and the demolition and commercial and industrial waste sections, we have a lot of heavy materials. We've talked about it today. We have concrete, we have cement, we have steel, we have soil. When you look at a project and when you review all the elements, which is something I like to do, you can see that the smaller segments, the smaller materials that are lighter, plastics, cables, and traffic lights, or in general lighting, they fall under the radar and they are not looked after properly. So I would say there is a responsibility from government and state government to really step up in the future and provide more mandatory targets. Perhaps there is a landfill ban targets that are put in place, targets for include using sustainable procurement to procure recycled content of products more, to drive change in a different way, because this will also help projects. The targets are good, but they're not good enough to drive the change that we really want to see in this space. And I encourage everyone, just as a final thing, we have a strategy here in Queensland that's a waste strategy, and you can have your say and put an input in if you would like to see more stronger targets.
And I guess for Manji, who was from New South Wales, it's probably worth keeping an eye on the New South Wales government's protection of the environment policy for sustainable construction that's currently in consultation, which has mandatory recycled materials mandates essentially for public works projects. So this will be our sort of last main question before we go to other audience questions. And for Linda and Jess, can circularity ever be truly cost effective without relying on external public policy or other sort of subsidy incentives to make it work? We might go to Jess first and then Linda.
Thanks. I think, well, things become cost effective when they're produced at scale and when the demand exists. So when we're talking about innovative products, we're looking at, particularly with circularity, we are looking at more innovative products than we've got on the market today, because the products we have on the market today are not circular. So when we're looking at innovative products, we're looking at our early adopters. Those are the people who are going to do things at risk because they want to build a better world. Those people will then help with testing, with writing those specifications, with releasing that sort of data to be shared and then used on other projects. Then you've kind of got the followers, and then you sort of the stragglers behind. Policy helps those stragglers who wouldn't otherwise pick up those and those environmental incentives or circularity principles. So it does kind of provide a baseline, for how we believe people should be acting. So I think policy will definitely help, but I think it becomes those early adopters who will then, push the rest of us to pick up those innovations, move with them, include them in our projects because they've done testing and they've shared that information around. So I think once we've kind of gotten to a high demand situation, which is sort of beyond those early adopters, then we can start to see sort of cost-effective, innovative materials coming onto the market.
Thanks, Jess. So we might just throw to Linda to wrap us up on the pre-selected questions.
Yeah, so I guess I spoke a little bit about policy and that before. So I think long-term return on investment is really important to understand, and that savings are maybe not achieved initially, but over a longer term. And definitely when it comes to policies, that we don't have to always have a policy to see that it's truly cost efficient, but across a longer period of time, if you want to build for, like I was mentioning before, durability, or when you even consider product as a service. And an interesting thought here is that could we actually build infrastructure in the built environment as a product as a service in the future, perhaps. And when you do that, you do need a little bit of help from policy to drive that change. But can it be cost efficient today? Yes, it can. And another example that we haven't talked so much about today, but we use on our projects, we can use a lot of artificial fertilizers and so on, and in change instead we can do recycled organics. And that is one of the areas where if you actually look at the cost efficiency, there is efficiencies to be made by the farmers if they change around, etc., and use these fertilizers and also on our projects if we do this long term. But there is as always this little bit of a hurdle that needs to be jumped over, and if we can get stronger policies to drive that change, I do think that circularity would move quicker and faster, especially if we look at other countries abroad in this space as well, where they have stronger targets. They're moving in a faster and more rapid space than we are here.
Yes, there's quite a lot of catch up to be had, but not to say that we can't get there, and the momentum's moving in the right direction. So we'll move on to hopefully a few audience questions, although we're rapidly running out of time, just because the conversation has been so fantastic and fruitful today. I'd like to move to a question that was submitted ahead of this conversation by Andrew from Victoria, and I'll direct it at Jody initially. It's with Australia's unique issues of vast distances for trucking and travel, how can remote renewable energy installations remain connected to circular and regenerative solutions?
Yeah, thank you, Andrew. That's a great question. I think rural and remote communities and locations, they live these challenges every day. That's their everyday. And I think their big advantage is that they have a history of making do with what they have. They have a history of being very innovative. So I think that there's a huge opportunity to push the boundaries around challenging the brief and being bold, looking at is there early planning you can do? Can we push the boundaries? Is there opportunities that are nearby that are local, that aren't 1,000 miles away? Can we look at the waste hierarchy? Can we plan early? Can we maximize on-site reuse? I know for renewable energy installations, an organisation I'm working with at the moment has I believe it's in Europe, but they have a plant that recycles the blades of wind turbines now, and they incorporate that material into things like sneakers and a whole range of other things. So I think there's a huge opportunity. There's lots of things happening. How do we keep connected? I guess we keep having these conversations. One example is, keep keep in contact with Engineers Australia and all the different presentations they're doing. Look at your particular industry or your key area material that you're looking at. There's a range of organisations and opportunities to upskill and learn and expand your knowledge, but also look at communities of practice. Are there other like-minded professionals or people in your industry or your even maybe not your location, but are there other people who have similar challenges? And could you maybe set up a call, have a chat, exchange ideas, talk about what are you doing that works for you? Here's something we're doing that's good. Maybe we could try that, and look at those, I guess, opportunities to embrace the circularity. It doesn't have to be from importing materials from miles away. You can look at your local area, and even on-site reuse, I think, is a massive area that we overlook. It's easy to import virgin materials rather than investigate and plan to use on-site existing materials. So I think there's a huge opportunity.
So it's looking like we're at time today, but I might just sort of invite the panel that if they had any sort of last questions or something that they wanted the audience to walk away with today, I'd welcome you to share that now before we sort of wrap up the session. I go to Luke first if you had something to share.
Oh, look, yeah, probably my three main points is, maximising, the reuse of existing structures, designing structures for longer design lives, and collaborating early on in the process. Sustainability is not an outside discipline, it's integrated across.
Jess, if you'd like to go next.
Yep. So my sort of top three go-to positions is sort of challenging the brief, putting material where it's needed, so going through that optimization process and using the best material for the purpose. Don't just rely on lower embodied carbon or higher embodied carbon because it's the flavour of the month. Make sure it's fit for purpose.
Alrighty, Jody, and then lucky last Linda after that.
Yeah, I guess I want to back up what Luke and Jess said is, we need to be bold. We need to challenge our briefs and our requirements. Where are the opportunities to make change? and how do we facilitate that change so that it has maximum benefits for not just the project, not just costs, not just reducing risk, but also for the wider community as well. Can we do it more efficiently? Can we minimize waste? Can we even eliminate waste? Can we put the question back to our suppliers and our supply chains? This is waste. We don't need this. Please take it back.
And Linda, your final comments.
So yes, thank you. So I would obviously say that I agree with everything that everyone else has said, and I guess the other thing to consider as well is that we really do consider what we need and refuse when we can, and we have to take ownership and build smaller and also adapt to a lower resource efficiency world and using less material. So that's also important. And then when it comes to companies like SMEC and others, we have to take the responsibility and really educate and empower our engineers so that they feel equipped to also empower the clients and share the knowledge, and then collaborate. And then we will take one step every day, and eventually circularity has become something that has gone from unfamiliar to familiar.
I'd like to thank everyone for joining in this conversation that's actually gone over time today because we've had such a fun time discussing circular economy. And I'd like to extend my gratitude to Jess, Linda, Jodie, and Luke for their contributions today and their time. I would like to thank Engineers Australia's industry partner, SMEC, as well for their support in this webinar. If you don't mind, please completing a short form, which is linked to the description box below to help us improve and plan our future sessions. Thank you again for joining us, and we hope to see you at our next Thought Leaders event. Enjoy your days.